So in this lecture number 2, we are going to see problems on Newton's interpolation formulas. So answer the first problem. Using Newton's forward formula, compute the pressure of the steam at temperature 142 degrees centigrade from the following steam table. First row will contains temperature 140, 150, 160, 170 and 180, and the pressure is 3.7, 4.9, 6.3, 8.1, 10.2. Okay, so these are the values which we can get from the experiment. Okay, and if you want to find in between values, then that we can get by Newton's formula, Newton's interpolation formula. For which value we want to find the term, means for 142 we want to find the pressure. So we have to check this value is in the upper values or in the lower values. If these values is near to these upper values, then we use forward formula. If it is near to lower values, then we use backward formulas. These values are denoted by x0, y0, x1, y1, x2, y2, like that. This is last value is x and y. Okay, this terms and the difference between any two values of x, successive values of x, that will be h, and that must be same for all these terms. Means you can see the difference between first and second value, it is 10, second and third 10, third and fourth also 10, and if we take the subtraction of these two values, that is also 10. Okay, whenever the difference between these values is same, then only interpolation formulas can be applied. If it is not same, we cannot use Newton forward or backward formulas. We have to use another method. Okay, so this method for such type of terms only, this method can be used. Now just recall the formula, Newton's forward difference formula. Last time we have taken this formula, y is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial delta square y0 plus u into u minus 1 into u minus 2 by 3 factorial into delta cube y0 plus dot dot dot. Now what is u, what is h? Okay, x is nothing but x0 plus uh, that is u is given by standard formula x minus x0 divided by h. X0 means this first value. H is the difference between any two successive values of h, that is 10. So h is 10, x0 is 140. So u become x minus 140 by 10. So we can put that value of u into these formulas. These values of delta square, delta cube, that we can find by constructing a table. So firstly, construct a table from this. Take temperature as x, take pressure as y, and construct that difference table. Very easy way to construct that table. So taking these x values and y values, just take the subtraction of these two values. The next value minus the previous value. Next value minus previous. By that we can get the delta term. So the value of delta y will be 4.9 minus 3.7, 6.3 minus 4.9, that is 1.4, 8.1 minus 6.3, that is 1.8, 10.2 minus 8.1, that will be 2.1. Okay, these are the values of delta. These are the forward differences. First forward differences. By same way, we can find the second forward difference. Take the subtraction of this first forward differences. That gives us the delta square. Second forward differences. 1.4 minus 1.2, 1.8 minus 1.4, 2.1 minus 1.8. That gives us the values of delta square. If we take a difference between these values, then it gives us the third difference, delta cube. So the value of delta cube will be 0.4 minus 0.2, that will be 0.2, 0.3 minus 0.4, that will be minus 0.1. Okay, continue until we get a single value. So take a difference between these two, that gives us the next difference, fourth difference, delta raised to 4 y is equal to minus 0.3. Okay. Actually, for forward and backward, we are having the same table, only notations are different. The same table is for the backward also. In that case, these differences are nothing but nabla y. This will be nabla square y. This is nabla cube y, like that. Okay, same table, only notations are different. If we want to use Newton forward difference formula, then we consider this top values. Okay, we use these values. And if we want to use a backward difference formula, then we use this bottom values. Okay, but here in this problem we want the forward difference, so we are using this top values. This is the value of y naught, this is the value of delta y naught, this value is delta square y naught, this is delta cube y naught, and delta raised to 4 y naught is minus 0.3. Okay, so this first all these top values are nothing but delta values: delta y naught, delta square y naught, delta cube y naught, delta raised to 4 y naught. Now put these values into the formula of Newton's forward interpolation. Okay? So use that standard formula, substitute all these differences into that formula. Putting the values, y will be y naught is 3.7 plus u into delta y naught, that is 1.2, u into u minus 1 by 2 factorial into delta square y naught, that is 0.2, all this term into delta cube y naught, and all this term into delta raised to 4 y naught. There are no further subtraction possible, so no need to write the further terms. Okay. Now we know what is u. U is x minus x naught divided by h. So make use of that term. We want to find y when x is 142. So take x as 142. X naught we know 140, first value of x, divided by h. H is 10. So u will be 142 minus 140 divided by 10. And that comes up to be 0.2. So put this 0.2 in this and simplify it. Okay, simple calculations are there. So do that calculation. So substituting, we get 3.7 plus 0.2 into 1.2 plus 0.2 into 0.2 minus 1 by 2 factorial into 0.2 plus 0.2 into 0.2 minus 1, 0.2 minus 2 by 3 factorial into 0.2. Okay, same way put it into this last term also. Okay, so by doing this simple calculation, we can easily get the value of y. So y will be 3.7 plus 0.24 minus 0.016, 0.0096 plus 0.01008. And so the answer will be, or the addition of all this term is 3.9437. So value of y at 142 is 3.9437. Okay. So what is the important thing we have to remember for such type of problems? Important is remembering the Newton's forward difference formula and the table. From the table, we get all the values of forward differences. First forward difference, second forward difference, third forward difference. Then for forward difference, x will be, u will be x minus x naught divided by h. H is the difference between any two successive values of x, that is throughout fixed. So we can take that value, x minus x naught. X is the value, given value, x naught first value of x, take the subtraction divided by h, that gives us u, and do substitute the values in this formula. Simple calculation gives us the answer. Okay, so this interpolation is a very important and easy technique to find a value of unknown term if the distribution, if the tabular values are given for x and y, where x is equispaced value. Okay, the difference between any two successive values of x must be same. That time only we can use this interpolation formula. Okay, so in this problem, the pressure at steam, pressure of the steam at this temperature is 3.9437. Now consider the next problem. Using Newton's backward interpolation formula, find y at 62 from the following table. Values of x are 40, 45, 50, 55, 60, 65, and the values of y are 184, 204, 226, 250, 276, and 304. Okay. So again, first write down what is the backward interpolation formula. It is, if you remember forward, then what are the changes we have to make? Wherever negative sign is there, we have to make it positive, and wherever x naught is there, make it xn. Okay, so that is the easiest way to remember the formulas. Instead of y0, we take yn. Instead of plus minus term, we have to take plus term. Okay, so this y will be yn plus u into nabla yn plus u into u plus 1. There we have u into u minus 1. For backward, it is u into u plus 1 divided by 2 factorial into nabla square yn plus u into u plus 1 into u plus 2 by 3 factorial into nabla cube yn plus dot dot dot. Now, what is the formula for this u? For backward, u is x minus xn divided by h. For forward, we use u as x minus x naught divided by h. For forward, we take x naught term, and for backward, we take x naught, xn, yn terms. Okay. Now this last term will be xn, and this is corresponding yn term. First value is x naught, yn, y naught, and last values are x naught, xn, and yn. Now what is the difference between these values? Difference between any two values of x. Here you can see it is 5. Okay. If you take subtraction of any two successive terms, it is same. It must be same. So here it is 5. So h is 5. 65 minus 60, or 60 minus 55, or 55 minus 50. Any difference you take, any two successive terms, difference between them is h. So last term is xn, that will be 65, h is 5. So u will be x minus xn divided by h. Okay. Forward is x minus x naught by h, backward x minus xn divided by h. So it will be x minus 65 divided by 5. Okay. So we have to put this value of x into it. We need to know all these backward differences. So we have to prepare a table exactly same way how we prepare the table for forward difference. By same way we can construct a table for backward differences. Only notations are different. Table format will be exactly same. Okay, so use that table. Take the subtraction of these two values of y. That gives us the backward difference. 204 minus 184, 226 minus 204, 250 minus 226, 276 minus 250. Okay, like that. 304 minus 276. Okay, that is 20, 22, 24, 26, 28. Okay, this will be nabla y. Okay, these are the same values for delta y. So delta y and nabla y, the column will be same. Only thing is this will be delta y naught, and in terms of nabla it is nabla y1. Only change with the notations. This will be delta yn minus 1, and it is nabla yn. Okay, so only change with the notation. Otherwise construction will be exactly same. Only change with the notation. This will be nabla square. Subtraction of these values uses nabla square. 22 minus 20, 24 minus 22, 26 minus 24, 28 minus 26. Take the difference between these. That gives us the next term. Nabla cube, third difference. 2 minus 2, 2 minus 2, 2 minus 2, 0, 0, 0. If you take further differences, that will be definitely 0. So if you want, you can write it, or otherwise you can directly put zeros in the formula. Okay, so up to 5 we have to go, because subtraction of these two we can take. So fifth backward difference of y is 0. as in this problem, we are using backward difference formula. So we are to take these bottom values. If you are using forward interpolation formula, then we take the top values. If you are using backward interpolation formula, take the bottom values. So what are these bottom values? This is the value of yn. This is delta yn. This is delta square yn, delta cube, delta raised to, oh sorry, nabla, nabla square, nabla cube, nabla raised to 5 yn. All these terms are 0. Last three terms are 0. Okay. This is delta square yn. This is 2, and rest of the terms are 0. Okay, this is 2. A mistake I have taken 0. It is 2. Okay. Now put all this value into the standard formula. We know what is a formula. So put all this value into that standard formula. Okay. So it is 304 plus u into 28, u into u plus 1 by 2 factorial. This is actually 2 plus all this term into 0, all this term into 0. Okay. Next term is also 0. So no need to write the further terms. Now, what is we want to find y for x equal to 62. Okay, so taking x as 62, u will be x minus xn divided by h. So it is 62 minus 65 divided by 5. So that comes out to be minus 0.6. Now put the value of u into this and do simplification. All these rest of the terms are 0. So by doing this substitution, we can get the terms y is equal to 304 plus 0.6 into 28 and simplify it to get the answer. So y at 62 is 287.2. Okay. So firstly, carefully remember the formulas for backward difference. Then prepare the table. For backward, use the bottom values. For forward, use the top values. Okay, and use the proper notation, simplify it, and that gives us the answer. Now consider the next problem. Estimate population in 1895 and 1925 for the from the following table: year 1891, 1901, 1911, 1921, 1931, and population y is 46, 66, 81, 93, 101. Okay. Now we have to find the population for these two values. Now this first value 1895, it will be near to this top values, and 1925, that value will be near to this bottom value. So for finding the value of y for this first value, we use the Newton's forward interpolation formula because it is near to top values. And for finding the value of y at 1925, which is nearer to bottom values, therefore we use the backward formula for finding the value of y for this term. Okay, so we have to use both formulas. So I'm just writing the formulas. Forward difference formula is y is equal to y naught plus u into delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus u into u minus 1 into u minus 2 by 3 factorial delta cube y naught plus dot dot dot. X will be x naught plus uh. That is, u will be x minus x naught divided by h. X naught is the first value, 1891. So using that, h is the difference between these two values. And you can see the difference between any two successive values of x is nothing but 10. So h is 10. So u will be x minus 1891 divided by 10. Okay. By same way, write down the formula for backward difference. Replace y naught by yn, replace delta by nabla. Okay, so replacing that terms, we get this term. On negative terms, take all the terms as a positive. So formula, backward formula is y equal to yn plus u nabla yn plus u into u plus 1 by 2 factorial nabla square yn plus u into u plus 1 u plus 2 by 3 factorial nabla cube yn plus dot dot dot. Okay, so if you look at these formulas carefully, then it becomes easy to remember. Replacing y naught by yn terms, replacing negative terms by positive, and then replacing delta by nabla. Okay. Now here H will be same because same table is there. So H will be same. Xn will be the last value 1931. And for this U will be X minus Xn divided by H. For forward we take X minus X naught. For backward we take X minus Xn. Okay. So Xn will be 1931 last term. U will be X minus Xn divided by H. That will be X minus 1931 by 10. Okay. So prepare the table. Table will be same for backward as well as forward. We use top values for forward difference formula, and we use bottom values for doing the calculation for backward difference. Okay. So prepare the table, taking the values of X and Y. Take the corresponding subtraction of values of Y. That gives us delta Y or nabla Y. You can use any notation because for both we have the same column. You can write delta Y or nabla Y. 66 minus 46, 81 minus 66, 93 minus 81, 101 minus 93. Okay. Take difference of these values. That gives us delta square Y or nabla square Y. Minus 5, minus 3, minus 4. Take more differences. We get minus 3 of minus 5, that become 2. Minus 4 minus of minus 3, that become minus 1. Take further difference of this. That gives us delta raised to 4y or nabla raised to 4y. Okay. Only change with the notation. Otherwise, values or table will be the same. For forward, we are using the top values. So y naught is 46, delta y naught is 20, delta square y naught is minus 5, delta cube y naught is 2, and delta raised to 4 y naught is minus 3. And for backward, we are using bottom values. So this is the value of yn 101. Nabla yn is 8. Nabla square yn minus 4. Nabla cube yn minus 1. Nabla raised to 4 yn is minus 3. Okay. So for forward and backward, we have same table, only change with the notation. Okay. Forward, top values, backward, bottom values of the table. Okay. Now put these values into the standard formulas. Take the corresponding value of X at which we want to find Y. So firstly, taking the forward difference table, using the formula, putting the values of Y naught, delta square Y naught, all that values, U will be X minus X naught by 10. X naught is 1891, and we want to find Y at this point. Okay, 1895. So taking that X and finding U, and U is 0.4. Let's put this 0.4 here and do the calculation. Simple calculations are there. 46 plus 0.4 into 20, like that. Put it into all the terms. Do the simple calculation. Simple multiplication is there. 2 factorial is 2. 3 factorial is 3 into 2 into 1, that is 6. 4 factorial is 4 into 3 into 2 into 1. That will be 24. So put that values and do this simple calculation. And that gives us the value of Y at 1895 is 54.8528. Okay. So this is nearer to the top value. So we use the forward interpolation formula and we get this value. Now for finding the next term, we have to use the backward interpolation formula. Substituting the value of yn, nabla square yn, all that values into Newton's backward difference formula. Now for backward, U is X minus Xn divided by H. Take X for which we want to find Y, that is 1925, minus Xn is 1931, and H is 10. It comes out to be minus 0.6. Now put these values into this and do the simple calculations. So I will be 101 plus minus 0.6 into 8 plus minus 0.6 into minus 0.6 plus 1 by 2 factorial into minus 4 plus all these terms. Okay, carefully do the calculation. Don't miss out any sign. Okay, that gives us the Y. So value of y at 1925 is 96.8368. Okay. So again, format of the table, same format for forward as well as backward. And carefully remember both these formulas, Newton forward, Newton backward. Newton forward, we use x naught, y naught. And for backward, we use x and y in terms. And carefully get u, and using this standard formula, we can get the value of unknown term. Now, these both formulas, by using these formulas, we can also find derivative of a function. Means if we know the tabular values of x and y, then we can also find derivative of y with respect to x, first order derivative or second order derivative, just making use of these formulas. Okay, last time we have taken that formulas. Now let's see how to make that uh, difference formulas to find a derivative. Okay, consider the problems on that. A rod is rotated in a plane, rotating in a plane. The following table gives the angle theta in radians through which the rod has rotated for various values of time t second. T is 0, 0.2, 0.4, 0.4, 0.6, 0.8, 1.0, and theta is 0, 0.12, 0.49, 1.12, 2.01, 3.20. Find angular velocity and angular acceleration of the rod when t is 0.2 seconds. Okay. Now we are given a time, we are given its rotation, angle is given, and making use of that, we want to find what is the angular velocity and angular acceleration. Now, what is the velocity and acceleration? Angular velocity is nothing but rate of change of angle with respect to time, and rate of change of any variable is nothing but the derivative. So angular velocity will be d theta by dt, and acceleration is nothing but rate of change of velocity with respect to time. Okay, or it is the double derivative of theta with respect to t. So what we have, the difference between the t, that we take it as h. Difference between these two is 0.2. Initial, we take it t naught at 0. U will be t minus t naught by h. Instead of x and y, we are having t and theta. If you want, you can convert this in terms of x and y, or you can consider the formulas in terms of t and theta. Okay, you can do by anywhere. Angular velocity will be rate of change of angle with respect to time, that is d theta by dt. Acceleration is d square theta by dt square. Okay. Now we want at which point? 0.2. 0.2 is in the top part of the table. So we use Newton's forward formulas. If it is asked for the value, say 0.9 or 0.8, that will be at the bottom. That time we use backward difference formulas. Okay, so we have to check these values nearer to which forward, upper terms or lower terms. Upper term, use forward formula. Lower term, then use backward formula of interpolation. Okay, as 0.2 is nearer to the beginning values of t, so we use forward interpolation formula of derivative. Okay, I'm just recalling the formulas. For that, we need to prepare a table, forward table. So same way, take the subtraction, 0.12 minus 0, 0.49 minus 0.12, 1.12 minus 1.49, like that. Take the subtraction, that gives us delta theta. Taking one more subtraction, that gives us delta square theta. Again, subtraction of these terms gives us delta cube theta. Then fourth forward difference, zeros, and subtraction of these two zeros gives us the fifth forward difference, that is delta raised to 5, 0. Okay. Use the top values, okay, for difference. So what are these values? Delta theta naught is 0.12, delta square theta naught is 0.25, delta cube theta naught is 0.12, delta raised to 4 theta naught is 0, and delta raised to 5 theta naught is 0. Okay. Now use the formula of derivative which we have derived last time. T is 0.2, so u will be t minus t naught by h. That is 0.2 minus t naught is 0 divided by 0.2. So u will be 1. And the formula of derivative d theta by dt, last time we have taken that 1 by h delta y, theta naught plus 2u minus 1 by 2 delta square theta naught plus all this term delta cube theta naught plus dot dot dot. And now substitute all these values into it. We know what are the values of delta thetas. Use that values, substitute the value of u as 1 and do the calculation. Okay, just simple substitution is there. And rest of the terms, delta raised to 4, delta raised to 5 are 0. So no need to write the further terms. All the terms are 0. So do the calculation with these 3 terms only. So we get the value of d theta by dt at t equal to 0.2 is 0.056. The second order derivative, if we take a derivative of this term with respect to u, delta theta will be 0. Derivative of this will be 2 upon 2, that is 1, delta square theta naught, we get this term. Derivative of this is this term. So like that we get the second order derivative. You can remember this as the formula. And now substitute the values of delta square, delta cube, delta raised to 4, value of u as 1 into this second order derivative and do the calculation. So it comes out to be 0.125. Okay, so we can use this forward as well as backward difference to find the value of unknown value of y, or value of derivative of y, or second order derivative of y. So for that we have to construct a table. Forward and backward table are one and the same, only notations wise they are different. For forward, use the top values of the table, and for backward, use the bottom values of the table. And by using the proper substitution and simple calculation, we can easily solve the problem.